Okay, number 3. We have an exponential, so we can use one of our rules of thumb. We'll let u be the thing in the exponent. The du then is 4x cubed dx. So what do we get here? We have a 2x to the 4th, which is fine, because that's going to be the 2 to the u. And we do have an x cubed dx. We'd like a 4x cubed dx, but once again I can multiply that by 4 as long as I divide that by 4. And so in the land of u, I get 1/4 integral 2 to the u du. So how do you integrate 1/4 2 to the u du? You can convert this to a regular exponential base e and integrate it that way. It depends what you want to do. I think most students are favoring just knowing this formula. So I'm going to go ahead and just apply that formula. I get 1/4 2 to the u over the natural log of 2 plus c. So I have 1 over 4 natural log of 2 to the u plus c. You've solved it for you, now you got to solve it for me. I want the x's back in. So I get 1 over 4 natural log of 2 times 2 to the x to the 4th power plus c. The ultimate check is take the derivative. Number 4. I can proceed as usual, e to the x, bring up the denominator, e to the x plus 1 to the minus 1 power dx. I can't multiply through because I've got a negative 1 power there, so I'm going to let u be the thing inside the parentheses. So what's your du? E to the x dx. So if I rearrange this integral, I have exactly what I need. That's u to the minus first, and that's our du. So in the land of u, it's a u to the minus 1 du. Natural log absolute value of u. Oops, I got a little ahead of myself there. Plus c. I can substitute the e to the x plus 1 plus c. This is perfectly acceptable on a quiz or a test. However, if we are a little careful here, e to the x is always a positive number, so e to the x plus 1 is especially positive. That means I don't really need the absolute values, and I can relax this to natural log of the quantity, e to the x plus 1 plus c. The ultimate check is take the derivative. Now, number 5, you might be having a little bit of deja vu. Number 5 is just the reciprocal of number 4. I'm going to integrate. I'll bring the e to the x up, e to the x plus 1. And when I bring this up, the exponent turns negative. What's nice about this problem is I can actually multiply this through. E to the x times e to the minus x. When you have the same base, you add the exponents. That's e to the 0, which is 1. So that's a 1 there, plus e to the minus x dx. The antiderivative of 1 is x. The antiderivative of e to the minus x, e to the minus x over negative 1, plus your constant. Grand final answer, x minus e to the minus x plus c. Once again, what's the ultimate check? Take the derivative. Okay, the last problem on the take-home, or on the checkpoint, is this definite integral. We can proceed as usual. Bring the x up as x to the minus 1. Bring this quantity up. to the minus 2 dx. We'll use our tried and true rule of thumb. I'll let u be the thing in parentheses. So my du is then 1 over x dx. So I'm going to try to rewrite this now, get everything into place. I'll take the 3 out as I usually do. I've got my quantity there. That's going to be u to the minus 2. And look at what I have left over. I've got the x to the minus 1 dx. Well, if I rewrite this, that's exactly what I need for the du. So in the land of u, I have 3 times the integral u to the minus 2 du. Now we have to be careful. This is a definite integral. The limits on this integral are not u values, they're x values. So we can change the limits from x's into u's by using our substitution back here. So we'll go off and do that on the side. U is the natural log of x plus 1. So when x equals 1, u is the natural log of 1 plus 1. But the natural log of 1 is 0, so u equals 1. So the lower limit remains 1. When x equals e, u is the natural log of e plus 1. The natural log of e is 1. That's 1 plus 1, which is 2. So in the land of u, we've taken this terrible looking definite integral and turned it into this not so bad. Take the antiderivative of u to the minus 2, you get negative 3u to the minus 1. Evaluating now from u equals 1 to u equals 2. So I get negative 3 times 2 to the minus 1 minus negative 3 times 1 to the minus 1. Well, 2 to the minus 1 is just a fancy way of saying 1/2. So I get negative 3/2 plus 3, because 1 to the negative 1 is 1. So I get 3 minus 3/2. That's 3 minus 1/2. That's 1/2, or 3/2. And that'll do it for checkpoint quiz 3.